We are going to discuss about the integrate rate of equation. So A is one product, it change into another product. That's why A tends to product. So rate of law is condition, the rate equal to minus dA by dt equal to k into Ax. So you are differentiating one quantity change into another quantity. So why are you using reduction? Maybe that mass will be decreasing in the beginning quantity. So k is the rate of constant, otherwise using the arbitrary constant. X is the order of the reaction. What is the order of the reaction? For example, if you take the milk to curd, curd to cheese. So there are three conditions there. So one by one. So X represent the order of the reaction. Now we go and see about order of reaction in the first order reaction. What is the first order? That means instead of X, if you have 1, what is the result? At time 0 to t from quantity A not to A. So order of reaction for the first order we can take like that. So dA by minus dA by dt. We can write here dA by dt equal to k into instead of x I take 1 because I am going to verify the result for first order reaction. So you can take dA by dt equal to k a power 1. Now here dA is a function with the same quantity, that we can write exchange and multiply d into a, bring the a in denominators, multiple of a, that is a into dd. You use the one mathematical variable separable method. So variable with respect to function you are separating. So dA is a function that react to the variables a. So dA with a. In mathematical use like that. For dx by we have y, here x is there. So bring the x this side, become along with the dx. So dx equal to y. So variable separable method you are using mathematical. So like that you separate the term with the dA to a and dd. Here k is arbitrary constant. So you can maybe think y k along with the dd is there. K is a constant. So don't worry about k. Here what are the variable? A is a variable, d is a variable. Time. So time is the mass of the product. So now we are going to find the value to integrating on both sides. So integrating on both sides, so take negative out of integral. So integral of, we can write as a 1 by a into dA equal to k is arbitrary constant, take out of integral and write dd. Okay, they asked to take the limit from the mass a naught to a. So the lower limit take as a naught, upper limit take as a. Here 0 to d sometime. So generally I am going to verify in the first derivative means one product to another new product. Maybe if you manufacturing from that we can take another one new products. There are many things are there. So like that I say milk to curd, curd to cheese. Like that one by one you can go. So we are going to discuss about the first order reaction only. So now we are going to integrate. In mathematics we can have like that. So 1 by x into dx. Integral of 1 by x here use as a log x. But you cannot use log x, you use long. So ln only going to use. Integral of 1 by x, variable denominator with power 1. If integrating it become a log x. Like that here variables 1 by a with dA. So instead of x here a is there. If integrating the minus already is there, it take outside. Now it become a long. Instead of log, here using as a long. So long a. Then use the upper limit and lower limits. A naught and a. So here k, like that you know integral of dx, it become x. Integral of dy, it become y. Like that. Integral of td become a d. So you can substitute limit 0 to k, t, upper limit and lower limit. Now substitute the limit, upper limit, lower limit. Then substitute the upper limit, lower limit, maybe it become minus common. Then we can have just substitute the upper limit and lower limit. So minus of log, instead of, this is a variable, instead of a substitute upper limit, same a only will come. That means instead of d, substitute d like that. So instead of a, substitute again a. When substitute lower limit, we can minus, then substitute the lower limit. It's a rule. Upper limit value, then minus of lower limit value. So log into the lower limit value a naught equal to k into here d minus 0. Upper limit value is d, lower limit value is 0. Now according to the log condition, so log a minus log b. So we can write as a log of a by b. So negative value write as a denominator. Same following log also. So in log of a minus log of a naught, we can write minus is a general. So write here minus of log a. Then by, we can write as a general. Take log common. So log n a by a naught equal to kd. Still we have minus is there. If you maybe multiply minus inside and take apply log also fine. Better we can multiply minus inside. Multiply minus inside. So minus of log n a, then plus log n a naught equal to kd. Then exchange right also fine. So log of a naught minus of log of a equal to kd. If take log common, then a after negative value write in the denominators equal to kd. Now we want to find the value of change into log. When you multiply along with the log, if you multiply 2.3, so 2.303 log, that is equal to log. Maybe you can write as a log equal to 2.033 into log. If you multiply 2.03 value with log, it become a log. So you want to change log into log, just to multiply this value. So I can rub this side. So you can if change a log into log, so multiply 2.303, then become a log of a naught by a equal to kd. Now again apply inside the log condition. You want to find the k value, then bring the d this side. 2.03 log of a naught by a equal to, multiply become a division, it become a k. So finally you can write a k value equal to 2.03 by d log of a naught by a. They asked to write the same term in the form of y equal to mx plus c. If you want to write the y equal to mx plus c, already we have the equation 1. Minus of dA by a equal to kd. So you can write as a y equal to mx plus c term. From take as this take as equation 1. This equation 1, you want to write y equal to mx plus c. So y is a function. Here your function is log a. So bring log a to next side. So log n of a naught. Then it become minus of kd equal to log n of a. That is stand for y. It is a stand for y. So log n is a constant term. This is stand for c. It's a mx value. So this is a y equal to mx plus c. We want to rearrange like that. Log of a equal to. So log of a equal to minus of kd plus log of a naught. This is a form of y equal to mx plus c. This is the value of k for the first order of reaction. This is a y. This is a mx plus c. This is the form is.